In this section, we're going to look at linear functions and their applications, and we'll look at how they can be used as mathematical models. Well, linear functions may be used in models that solve practical problems. If x is the number of widgets produced, and I think we've seen that term before, but widgets is basically just an imaginary object that a company produces and sells. It could be pianos or baseball bats or really anything. So if x is the number of widgets produced by company ABC each week, then the cost function, which will denote C of x, gives ABC's cost to produce x widgets in a week. So it's also called, C of x can also be called the cost volume function. Cost and then volume typically refers to the number of items being produced. Okay, if C of 10 is 2,000, we interpret that as the cost of 10 units will be $2,000. So it will cost ABC $2,000 to produce 10 widgets. Remember, the variable that goes inside the C of x, or the number that's put in there, is always the number of units that are produced. All right, let's look at a simple example. The Jones Company manufactures its products at a cost of $111 per unit. The firm's fixed cost is $1,900 per month. So let me take a minute and describe what fixed cost means. Fixed cost would be something like rent for the building, utilities, insurance, a fee that is paid every month no matter what, whether you produce 0 units or whether you produce 1,000,000 units, you've got this fixed cost, and in this example, it's $1,900 per month. So the cost function would be C of x is 1,900, that's the fixed cost, plus $111 times the number of units that get produced. That will be this company's monthly fixed cost. So you can see, obviously, if x is a 0, that means 0 units are produced. The cost function would give us $1,900 plus 0. So if x were 1 unit, the cost of producing 1 unit would be $1,900 plus 111 times 1, which is 111. Where x, as always, just as another reminder, is the number of units. Number of units produced and a number of units that they've produced and are going to sell. Okay, number 3. A linear cost function or cost volume function has the form C of x is equal to, let's see, A of x plus B. A times x plus B. I said that wrong. Okay, so the cost function looks something like this, where x, as always, is the number of units. B, notice it's not multiplied by x, it's just a constant number, like in the previous problem, 1,900. B would be the fixed cost in dollars, and A is the unit cost. In dollars. Usually it's called the variable cost. It varies. A doesn't vary, but this AX will vary based upon whatever x is equal to. So C of x is the total cost in dollars of producing X number of items. So here's the cost function. And notice I wrote it in the reverse order, these two terms. It doesn't matter. I could have put the B first if I wanted to. A is the variable cost, the cost per item, and B is the fixed cost. Number 4. In the Jones Company example above, that is where we had this cost function. C of x is 1900 plus 111x. The unit cost is $111 because each unit costs that much to produce. And the fixed cost was the $1,900 number right here. Determine the cost to produce 50 items per week. Well, all we have to do is come up to this cost function and plug x equals 50 into this. So we get C, the cost of 50 items, is 1900 plus 111 times 50. And that would give us 1900 plus, if you multiply 111 times 50, you get 5550. And that turns out to be $7,450. Oops, I had that off the screen there. Okay, so the cost function, if you produce 50 items, the company is going to spend $1,900 in fixed costs, and then 111 times 50 items at $111 per item, which turns out to be $5,550. So the cost function is going to be the sum of those two, $7,450. All right, the last part of number 4, we're going to say determine how many items are produced if the monthly production cost is $14,665. Well, how many items? Remember, that's always X that we're looking for. And the monthly production cost, well, we're going to replace this. This is the monthly cost. So we're going to put 14,665, that's C of x, the cost function. And that's going to be equal to 1900 plus, how many items? It's $111 per item times x. And then all we need to do is solve for x. So when we subtract 1900 from both sides, we get on the left 12,765 equals 111 times x. So all we need to do now is divide both sides by 111, and we find out that x is equal to, I'll rewrite it, 12,765 over 111, which is equal to 115. So the question we answered, how many items are produced if the monthly production cost is this number? Well, x would be 115.